The interstellar wanderer has returned, brighter and clearer than ever before. The James Webb Space Telescope has turned its golden eye back toward the unknown. What it has seen is shaking the scientific world. For the first time, humanity has captured a sharp image of the mysterious Three-Eye Atlas, a silent traveler drifting beyond our solar system. Three-Eye Atlas is only the third interstellar visitor ever found, after Oumuamua and Two-Eye Borisov. But unlike those faint traces, Webb has revealed it in full detail. This is no blur or data blip, it's a portrait rich with light, shape, and mystery. For astronomers, this is a bridge between stars. We are not just detecting a passing rock, we are looking directly at a piece of another world. The image shows an irregular, glowing body wrapped in a thin, ghostly halo of reflected light, a whisper of its long journey through space. Webb's infrared vision uncovered a surface etched with ridges and fractures, each mark a record of impacts and cosmic wear. Unlike smooth Oumuamua, Three-Eye Atlas is rugged and ancient, shaped by both fire and ice. Spectral data reveal frozen carbon, silicates, and organic molecules, the ingredients of planets and perhaps life itself. This hints that the seeds of worlds are scattered across the galaxy. When the first image appeared, silence filled the control room. Scientists realized they were seeing matter that did not belong to our sun, a relic from another star system, now drifting through ours. Three-Eye Atlas has traveled for millions of years, its path carved through interstellar darkness until fate placed it within Webb's reach. Faint heat beneath its icy crust suggests it's not entirely inert, maybe warmed by radioactive decay or slow tumbling motion. This isn't a dead fragment, it's a living relic, still changing, still whispering its origin. The object was first spotted by the Atlas Survey in Hawaii, built to find near-Earth asteroids. When its hyperbolic path was confirmed, astronomers knew it came from beyond our sun. Ground telescopes could only trace its motion and brightness. Webb was needed to reveal its face. Far from Earth's atmosphere, Webb's infrared mirrors cut through darkness and captured the chemistry of this traveler. The data shocked researchers. Its elements suggest it formed around a different kind of star, maybe a cool red dwarf. Humanity now holds a fragment of another solar system, a message carried across the Milky Way. Its reddish hue, caused by tholins, radiation-made organics, matches those found on outer system comets. They are thought to be precursors to life. That means the seeds of biology may travel through space, waiting for the right world to grow. Its uneven rotation shows it's a loose cluster of rock and ice, a fragile rubble pile held together by gravity and cold. Webb even saw faint jets of vapor from its sunlit side, proof that volatile ices still remain within. This gentle activity forms a glowing halo, a comet-like shimmer that defies the frozen depths. Each observation of Three-Eye Atlas forces science to rethink how worlds form and drift between stars. It reminds us, the space between suns is not empty. When Webb's first image of Three-Eye Atlas reached Earth, the world of science fell silent for a moment. What appeared on the screen was not just data, it was a message, whispered across the dark between suns. For generations, astronomers had dreamed of seeing something like this. A piece of another solar system, close enough to study in detail. Now, that dream had turned into a photograph glowing in golden light. Researchers gathered around the monitors, their faces lit by the reflected glow of a world that was not our own. The more they studied it, the more impossible it seemed. Three-Eye Atlas was not simply a comet or asteroid, it was a survivor, a wanderer forged around another star. Its chemical signature told of a different origin, a system with cooler light, perhaps a faint red dwarf long since faded. The ratios of carbon, oxygen, and nitrogen revealed a chemistry unlike anything born beneath our sun. Its elements whispered of distant processes, of storms and collisions that shaped it before our species even existed. The surface is rough and ancient, a landscape of frozen ridges, fractured stone, and icy scars. Webb's instruments showed streaks of dust clinging to the crust, fused together by radiation over millions of years. In false color, it glows with deep crimson and bronze tones, evidence of tholins, complex organics created by radiation. The same kind of molecules that once drifted through the young solar nebula, perhaps helping to spark life on early Earth. For astrobiologists, this is a revelation. If such molecules can endure interstellar travel, then the building blocks of life are not bound to any single world. They are cosmic nomads, carried from system to system by travelers like 3I Atlas. Its movement through space is graceful yet uneven, a slow tumble that betrays its fragile nature. It is not a solid world, but a cluster of fragments held together by gravity, ice, and the memory of its creation. Webb's cameras captured faint jets of vapor venting from its sun-facing side. The sunlight, weak yet relentless, warms its crust just enough to awaken pockets of frozen gases. Each puff of vapor forms a veil around the object, a shimmering halo that gives it its ghostly glow. This behavior astonished scientists. They had not expected an interstellar object, drifting through such cold emptiness, to still be active, still breathing. It means that within its shell lies a trace of warmth, a memory of the star that once gave it light. That faint activity turns 3I Atlas from a relic into a living witness of cosmic history. The discovery reshapes the story of how planets form and die. If such wanderers exist in abundance, then every solar system may send its fragments outward, tiny ambassadors drifting through the galaxy. Over time, these fragments mix and mingle, seeding other systems with dust, ice, and organic matter. The galaxy becomes a single vast ecosystem, each star contributing to the evolution of all the others. 3I Atlas may have once belonged to a planet shattered in its youth or ejected by gravitational chaos. Now it sails through the void, carrying with it the story of its lost home. Every atom in its structure has journeyed farther than imagination. And yet, through Webb's golden mirrors, those atoms now share their light with us. Each photon captured by the telescope traveled billions of kilometers through empty space, bouncing off alien rock, then across a vast gulf to reach human eyes. That light, born around another star, passed through the darkness of eternity and touched a machine made by human hands. It is a meeting of two civilizations, one natural, one created. The success of Webb's observation is not only scientific, it's a celebration of curiosity itself. It shows how far our vision has stretched, from the first stargazers on Earth to a telescope floating beyond the moon, watching a visitor from another world. Even as 3I Atlas moves farther from us, its image remains, a quiet symbol of connection. It reminds us that exploration never truly ends, it simply shifts from one horizon to the next. Because in the vastness between stars, every wandering fragment carries a story. And in learning their stories, we begin to understand our own. We are made of the same dust that drifts between suns. We are part of the same endless journey. And somewhere out there, in another sky, someone, or something, may be looking back, wondering about us, as we now wonder about 3I